Welcome back to the deep dive. Today, we're exploring a transformation that is, well, it's quietly changing one of the oldest industries on the planet.
And one of the most traditional, right?
Exactly. Construction, we're talking massive building sites, really complex logistics.
Millions of dollars riding on every single decision.
Yeah, precisely. And our sources for this deep dive are all pointing to the revolutionary role of algorithms in managing these places, specifically something called swarm intelligence, SI.
Right. And this is the tech that allows, autonomous cranes, dozers, and even human crews to work together.
But without constant, direct central oversight. That's the key.
That's the entire game changer.
And what I find so captivating is where the inspiration comes from. It's not some top-down military planning model.
No, not at all.
It's inspired by nature. I think about a flock of birds, how they move together, or ants, how they just efficiently find food. It's nature's blueprint for logistics. Okay, let's unpack this.
That nature analogy is just perfect because it gets right to the heart of what makes SI so different from, say, traditional AI.
How so?
Well, swarm intelligence is all about collective behavior. It emerges from a system where every agent, let's call it every machine, every worker, is only following a few simple rules.
Based on what's immediately around it.
Exactly.
Yeah.
Based on its immediate surroundings, its local information.
So that's totally different from traditional project management.
Oh, completely. Traditional management is centralized. You have one person, one master plan, a rigid schedule, and every single instruction flows from the top down.
And SI just flips that on its head.
It flips it. It introduces autonomy. So every component is constantly communicating, constantly adapting based on what the machine next to it is doing, or, what the ground beneath it is like. They all work toward a huge site-wide goal, but they do it through thousands of tiny localized decisions.
It sounds great in theory, this self-regulating structure, but, construction sites thrive on rigid planning. You've got a blueprint for a 50-story building. It demands precision.
Right.
How do these simple, decentralized rules actually manage the immense complexity of a modern construction site?
That's where the power of the algorithm comes in. It's the brain that integrates all these different data streams. Because on a modern SI site, we're not just talking about machines doing their own thing.
It does more than that.
Much more. We're integrating autonomous machines, sure, but also drones doing constant surveying and human workers who are all connected.
What kind of connection?
We're talking robust, low-latency networks, maybe a specialized 5G mesh, or even ultra-wideband tracking for, hyper-precise location data.
So the blueprint gets translated into, what, local rules?
You got it.
Yeah.
The complexity is managed because the blueprint's goals are broken down into simple, actionable rules. For example, a rule might be, if excavator A is digging within 5 meters, crane B must adjust its boom angle by 3 degrees.
So the crane doesn't need to know the entire project schedule.
It doesn't need to know a thing about it. It just needs to follow that one local safety and efficiency rule. And it does it perfectly every time.
That real-time communication has to be critical. The sources we read detail how SI algorithms optimize task distribution, allowing all these machines and crews to operate in tandem. It gets rid of those classic bottlenecks,
Yeah, where one crew is just standing around waiting for another one to finish.
Exactly. And this is where it gets really interesting. The actual on-site applications.
The most immediate one, the one you'd see right away, is autonomous machinery coordination. We're talking about the heavy hitters, cranes, bulldozers, concrete pumps.
The most dangerous equipment.
Absolutely. Their movements used to require constant human signaling, rigid schedules, just to prevent catastrophic accidents.
So, okay, let's make it concrete. You have 3 excavators digging in a pretty tight space. How does the SI system actually manage their workflow so they're not just constantly bumping into each other?
They're communicating nonstop. Milliseconds, we're talking. They're basically telling each other their next move and their current status.
Like a constant conversation.
A constant high-speed digital conversation. If excavator alpha starts digging in one sector, the algorithm instantly recalculates the available space, and it might reroute bulldozer beta to fill material in another sector. It's not just avoiding a crash.
It's optimizing the flow of material at the same time.
It's a dynamic choreography. And if one machine detects a problem, say the soil is harder than expected and it's slowing down, it instantly broadcasts that delay. The whole system, maybe 20 nearby machines, adapts their schedules on the fly.
But what about the people? It sort of sounds like we're just designing an environment for machines. I mean, the crew management side of this is crucial. How does the swarm manage actual human workers?
This is where it gets really elegant, I think. It applies that nature wisdom so directly. Just like ants leave pheromone trails to show where food is.
The system leaves digital trails.
Exactly. Digital data trails that guide the human crews. So if a machine finishes prepping a zone, let's say the concrete pour is done, that data instantly updates the system. The algorithm then finds the next available carpentry crew and reroutes them to that location.
So it's maximizing their productive time.
Aggressively. It's constantly looking at the project's overall velocity, making sure the automated parts and the people are in sync, and just driving down that downtime by seeing conflicts before they even happen.
That's fascinating. And that ability to coordinate must feed into the most advanced application, which is real-time decision-making.
Right, especially when things go wrong. Because construction sites are chaotic.
They're dynamic, they're always changing. You get sudden weather changes, material shortages, things you just can't plan for.
A constantly moving target.
So how does the system even get the data it needs to make a decision in, an instant?
It relies on a really dense network of sensors. We're not just tracking machine movement. We're using geotechnical sensors in the ground that can detect instability. Thermal imaging sensors on equipment that can predict a part is going to fail before it actually breaks. RFID or GPS tags on every single pallet of material.
So you know where everything is all the time.
To the inch.
Yeah.
And the swarm algorithm processes all of this data as it streams in. If a thermal sensor flags an engine that's starting to overheat, the system doesn't wait for a human to notice.
What does it do?
It pulls that machine out of rotation for maintenance and instantly reassigns its task to another available machine. The project stays on schedule, even when things break.
That ability to adapt on its own, it feels like a fundamental shift in how you manage risk. Okay, so we've dug into how it works. Let's pivot to the benefits. Why are these massive construction firms betting billions on this tech?
Well, if we connect this to the bigger picture, it's all driven by the ROI.
Yeah.
It's that simple. Efficiency, safety, and cost. And SI links its decentralized nature directly to all three.
Okay, so let's start with efficiency.
First, efficiency. By getting rid of manual scheduling and that constant central oversight, and by letting every agent self-regulate, the system just dramatically cuts wasted time. Some of the sources suggest a full SI rollout can cut non-productive work time by up to 20%.
20%? That's huge. That's time spent just waiting for materials, waiting for clearance.
All of that's a massive operational gain.
Okay, a 20% reduction is staggering. But what about safety? This is a notoriously dangerous industry. Is SI just about preventing machines from bumping, or is it a more fundamental change?
It's a fundamental change to the landscape.
Yeah.
The decentralized coordination reduces the single biggest cause of accidents on site.
Human error.
Human error in communication and judgment. These machines are programmed with absolute precise boundaries. It knows the location of every single worker through their wearables.
So tagged vests or helmets.
Right. So if the swarm calculates that the most efficient path for a huge crane boom brings it a little too close to a person, the system doesn't just slow down. It can automatically trigger a localized safety protocol.
Like what?
Like creating a digital geofence that instantly tells the human crew's devices to move elsewhere. Or it just halts the crane until that zone is totally clear. It's predictive safety. It keeps people out of harm's way before the danger is even really there.
So the system isn't just programmed for collision avoidance, it's programmed for preemptive human protection.
Precisely. And that minimizes accidents, which, translates directly into lower insurance costs for the firm. It's another financial layer.
Okay, finally, let's hit the bottom line. Cost savings. This sounds like an expensive system to put in place. Where do the savings come from to make it all worthwhile?
The savings come from every single layer of that optimized management we've been talking about. Because the system coordinates machines and crews with real-time material tracking, you basically eliminate the biggest source of construction waste.
Over-ordering materials, mismanagement.
All of it. Every piece of steel, every bag of cement is used exactly when and where it's needed. That reduces material wastage dramatically.
And I imagine the projects get done faster, too.
Much faster. The increased coordination and less downtime accelerate the whole project cycle. Finishing a multi-million-dollar project weeks ahead of schedule because your workflow is so optimized That creates immense financial returns. It completely outweighs the initial cost.
So it's not just a small improvement.
It's a structural optimization of capital and material from the ground up.
So what does this all mean? We've seen that these swarm intelligence algorithms modeled on, the collective genius of ants and birds are now turning on-site execution from something chaotic into something like a perfectly synchronized manufacturing line.
That's a great way to put it.
They coordinate every autonomous machine, every human crew member, and that makes projects vastly more efficient, inherently safer through this predictive routing, and ultimately just way more cost-effective.
Yeah.
Feels like a full-scale revolution.
And based on the material we looked at, the integration of these intelligent systems is setting an entirely new standard for the construction industry. This move toward autonomous, locally adapting agents. It's changing the baseline for what productivity even means.
And as we move into a more digital, more automated future, the sources describe the potential here as, and I'm quoting, limitless. But that leaves us with a really interesting question. If this nature-inspired, decentralized system can revolutionize construction, one of the largest, most traditional, and most chaotic industries on Earth, what other fields defined by huge scale and complex coordination needs are just ripe for the collective genius of the swarm? What industry, stuck in that rigid top-down planning, could use a dose of simple, local, adaptive rules to completely transform how it works? That's the thought we'll leave you with today.